here, but we'll look at some of this. We got these place values, and we do need to understand that at the decimal place like this, just to the left of the decimal, that's where our whole values are. Like we got our ones. Oh, that didn't come out right. Ones. Let me change this. And then after the ones is the tens position. And then we got the hundreds, which is kind of a long word actually. Hundreds. And then we got our thousands. Thousands. Then we got our 10,000s. Then we got 100,000s. And then after that we kind of start over in the ones position, but now for millions. And that's next. And then you'd have 10 millions, 100 millions, move on to billions, trillions, and then who knows what's after that, okay? But for now, this is usually about as far as we'll go. But this is just to the left of the decimal. To the right of the decimal, now we're looking at parts of things. Values, right? So ones, to reduce that, we would then have, this is now tenths. And that's really the biggest difference between the numbers to the left of the decimal and the numbers to the right of the decimal. Is it's kind of the same values here from ones, which is in the middle. You have tenths, it's the TH right there. And then the next one then would be hundredths. Hundredths. For a while, I suppose. But in any case, tenths, hundredths, and then thousandths. Then we got 10,000ths. And this again just continues. 100,000ths, millionths, 10 millionths, 100 millionths, and so forth. So when it says to write these out in words, we need to identify where the decimal place is on these. So let's look at 1, 2, 3 right here. 5.002. So this would be 5.002. And we just kind of, in words, put out whatever the place values are. Now, we don't say 5/1 for these. So we would just say something like 5. And that acknowledges the decimal, 5. And there's no tenths, there's no hundredth, there's only thousandths there. And there was 2 of them. So this would be 5 and 2. Sometimes we'll put a dash on that. Thousandths. 5 and 2 thousandths. Let's look at 2 as well. So 2, this one gives us 7.912. 7.9, oh, that's in the wrong place. 7, where the heck? 7.912. So this one also will go to the thousandths, but now we got 7. So 7, and again, that's where the decimal is. Now we acknowledge this one as 912, and that's how many thousands. So that's 912 thousandths. We don't say every place value on this, so it's not 9/10ths, 1/100ths, and then 2 thousandths. This would be considered 912. 912, and that's how many thousandths we have. We'll just finish on number 4 there. So we got this place value. There's no tenths. We do have hundredths and thousandths. So this one we acknowledge as 28 because there's no other numbers there to the left. And then it always is just whatever the place value is farthest to the right that we can acknowledge on that. So this one would just be 28 thousandths. 28 thousandths. That's it. Well, then it just wants us to write these. These numbers have been written as words, so we just need to write them out as digits. So this is 23 and, so that's where the decimal goes. So we'd have 23 and then 5 hundredths. So that means there's nothing in the tenths, and would have 5 of those hundredths, like that. The next one, 2,000, 1,100, and 426,000. So the and again, that's where our decimal will be. We got 2,000 and 11, so there's 11. There's no hundreds, but there's 2,000s. And then we got 426 thousandths. So we'll just write that out, 426. And then if we need more zeros either to the left of the 4, then we'll put them there. But let's just check. The 4 is in the tenths, 2 is in the hundredths, 6 is in the thousandths. So that's it. Now if that had been 426 ten thousandths, then we would have just placed a 0 right there to the left of the 4, but to the right of the decimal. So what about this next one, number 7? So it tells us it's negative 1,654, 1,654, and so there's our decimal. 29 ten thousandths, so we'll put a 29 here. And since it's 10 thousandths, would have a tenths, hundredths, thousandths, 10 thousandths. That means we need 2 zeros. 2 zeros right here. That keeps looking like a 6. That's better. And that would be the number. All right, let's look at number 10. We have this big decimal. It says to round to the nearest tenth. That's this place value. So we know we're going to have 15 point something. And to figure out what that value will be, we got to look to the number to its right, which in this case is 3. If that number were 5, 6, 7, 8, or 9, then we would round that up to 15.2, but it's not. What that means is that it's closer to 15.1 than it is to 15.2, or 15 and 1/10 instead of 15 and 2/10. And then the place value of the 8, let's look at number 8 here. Place value of that, 8. So we got the decimal value tenths, hundredths. So this one is the hundredths. So 17, when we're comparing decimal values like this, first thing we're going to want to do is just go to the number farthest to the left and look at its place value. The 6's are in the 1's place. The 1 and the 2, these ones are in the tenths place, but they're different now. Now, in this case, that means that we can ignore that 7. We can see that 2 is bigger than the 1 here, so it's going to eat the 6.2. I mean, if you compare this in money, right? $6.17 is less than $6.20. 18, though, that's the tricky one, because the number that is going to eat should be farthest to the right on the number line. Now, on this number line right here, we're looking at negatives. So this is -1. Here's -2. Negative 1.2, I mean, if we really zoomed in on this thing, that may be helpful. Right, we got 1, 2, and that's a negative 1.2. And then over here is negative 1.3. Well, negative 1.2 is right there. Negative 1.8, negative 1.28 would be about right there. So the number farthest to the right is this negative 1.2. And that means that it would eat the negative 1.2. So we have to be careful with those negatives, because in our mind we think, oh, the 1.28 is clearly bigger. But since it's negative, it's a bigger negative. And so you hopefully you'd want less debt, is the way that I look at it. So. This wants mixed numbers, and since we have a whole value, it's going to be 6 and something. Now right here, it'd be nice if we could just change this 375. If we just write that in the numerator, then that's fine, but we just, again, have to acknowledge the number farthest to the right, and its place value right there. The 5 is in the thousandths position, so I'm just going to make it over 1,000. And then from there, I can simplify. So I can see that these both are simplifiable by 125 is what I'm looking at. Now, you may have been thinking 5, and that's okay. You just have to reduce it a few times. But to save some time, I'm going to make this 6. 375 divided by 125 is 3. 1,000 divided by 125 is 8 is what I get. So this would be 6 3/8. So this one, this is negative, so it'll definitely be -3 and some stuff. Right here, we've got this 2, because that's all we got. And then its place value is the 10,000s. So I'm going to make it over 10,000. Well, we can simplify these by dividing both of them by 2, and that gives us 1/5,000th. So -3 and 1/5,000th would do. All right, this one is not going to be a mixed number because, again, we have no ones, anything to the left of the decimal value. Now, it is important to remember this is going to be negative, so just don't forget that part. Now, this should be a fraction, so I'm just going to write this 2 and 5 as a number, 25. Then, again, I just need to acknowledge the place value, the number farthest to the right. The 5 is in the hundredths position, so it's out of 100. We can simplify these by dividing both these by 25. So it becomes negative. 25 divided by 25 is 1. 100 divided by 25 is 4. That's as far as I can simplify that thing.